So in this current problem, let's look at this graph. I'm giving you a graph here for the function f of x, and we'll try to compute the limit at various points. So let's take a look at this point. For example, let's look at this limit. Let's say x goes to 1 minus for the function f of x. Please look at this limit. Please recall the meaning of this left-hand limit. For this left-hand limit, it essentially means that um, you are approaching the point 1 from the left-hand side, like this. And please go to the line, and you can imagine that you're traveling along this line, and you're approaching 1. You're approaching 1 from the left-hand side. So it's quite obvious that it is approaching 1, right? Although the actual point is sitting at the level 0 for the y value. But actually, I mean, if you just look at the fact that when x is approaching 1, what value does the function f approach? It is actually 1. So let's look at the second one, when x is approaching 1 from the right-hand side. So let's see what's happening. You see, you're approaching 1 from the right-hand side, from the values bigger than 1. And let's look at this line. You see, when you approach 1 from the right-hand side, you're actually approaching this point, which is the actual point where the function f of 1 is sitting in. So just to let you know, f of 1 is 0. So actually, it is approaching this actual point, which is 0. So you see, the left hand and the right hand limits are not the same, right? I mean, now if I ask you the limit when x goes to 1, are you able to answer this problem? You see, logically speaking, because of the fact that you see the fact is the left-hand limit, which is the answer you get from the part A left-hand limit, is not as the same as the right-hand limit. They are not the same. So it means the two-sided limit basically doesn't exist. If it exists, it essentially means that the left-hand limit must be the same as the right-hand limit. And let's look at more problems. Let's look at more problems. So how about I ask you the limit for x goes to 2, x goes to 2. Please look at this problem. Please look at this problem. The fact is like this. For the limit x goes to 2 from the left-hand side, let's see what's happening. You see, you go to 2 from the left side. Basically, you travel along this line. You are traveling along this line. You're approaching 2. You're approaching 2. And similarly, when you go to the right-hand limit for x to go to 2, you're actually going to 2 from the right hand side like this, from the right hand side like this. So it is actually a pro. So you see, actually they are the same. So and because the left hand limit and the right hand limit are the same, the value is 2. We can claim that when we take limit x goes to 2, the value of this limit problem is actually 2 because they are the same. You see, although the fact is that although the actual point f of 2 is actually 3, right? But you see, this graph basically gives you a sense that the actual point doesn't matter when you look at the limit problem. We care what value does f of x approach. What value does f of x approach? So please separate the two problems. The value that f of x approach may not be the same as the actual value of f of x at that particular point. Like this case, you see, like this case, f of 2 is 3. There's no doubt because the full dot is here. However, if you talk about when x is approaching 2, it's actually approaching 2, right? I mean, when x is approaching 2, the f of x is actually approaching 2. So it's actually obvious. And let's look at some other problems. For example, we can actually look at this one. We can actually look at this. X goes to 5 from the minus sign. And please check. In this case, x goes to 5 from the left-hand side. So you see, you are going down like this. And it looks like it is going down forever. So I think it's minus infinity. We can claim this because it just keep going down kind of vertical. It's minus infinity. And okay, so basically that's it to this problem. And we'll see more examples in the next couple of videos.